today's video, we'll be talking about formal geometry. And what we are going to be looking at is triangles and polygons. So we have 4 theorems here. The first theorem says that the sum of angles in a triangle is 180 degrees. The second theorem says that the exterior angle of a triangle is equal to the sum of the opposite interior angles. While the third theorem says the sum of the interior angles of any n-sided polygon is 2n minus 4 right angle. And the fourth theorem says that the sum of exterior angle of any polygon is 4 right angles. Now, what is the meaning of this? Let's move to the theorem 1. The first theorem says that the sum of angle in a triangle, the sum of angle of a triangle is 180 degrees. Now, drawing a triangle like this, meaning that addition of all the angles we have here, if this is triangle ABC, so the addition of all the angles we have here, let's say if here is 45 degrees, we are assuming, let's say here is 90 degrees, definitely here too will be 45 degrees to make everything to be 180 degrees. So that is what the first theorem is saying. Again, the first theorem says that if you sum up the angles of a triangle, it must be equal to 180 degrees. Please take note of this. And remember that this topic is basically for SS1 students in SS1. Now let's move to theorem 2. Theorem 2 says that the exterior angle of a triangle is equal to the sum of the opposite interior angle. How? The sketch will look like this. If I have this type of angle like this, now this angle here is an exterior angle. So this angle here, let me put it as question mark here. This angle here is equal to the addition of these two opposite angles, meaning that the angle A and angle B, if I sum up A and B together, it will be equal to this angle we have here. The angle we have here is what we call the exterior angle, while the angle we have here is what we call the opposite interior angles. So take note of this theorem very well. When you sum up this A and angle B together, you are going to get this exterior angle. Now the third theorem says that the sum of the interior angle of any n-sided polygon is 2n minus 4 right angle. Now look at this theorem 3. This theorem 3 actually says that the sum of interior angles is equal to 2n minus 4 times right angle. And remember that right angle is what? 90 degrees. So that is what this particular theorem is talking about. Meaning that when you sum up all interior angles, then it's going to give you 2n minus 4 times 90 degrees, whereby this n is the number of sides of that particular angle. Instead of you writing this 2n minus 4 times 90 degrees, you can as well write it as n minus 2 times 180 degrees. Now that is the formula to calculate sum of interior angle, and that is what theorem 3 is talking about. Again, theorem 3 says that the sum of the interior angles of any n-sided, that n means the number of sides, n-sided polygon is 2n minus 4 right angles. And I said the sum of interior angle is equal to 2n minus 4 times 90 degrees. We all know that right angle is an angle at exactly 90 degrees. So therefore, you can as well say it is what? N minus 2 times what? That times 180 degrees is still the same thing. And that is n minus 2 times angle on a straight line. Remember that angle on a straight line is angle at exactly 180 degrees. So that is what theorem 3 is talking about. Now let's move to theorem 4. Theorem 4 says that the sum of the exterior means outside, interior means inside. Again, exterior means outside, interior means inside. So the sum of the exterior angle of any polygon is 4 of right angles. Now look at this, 4 of right angles. What is right angle? 90 degree. So 4 of it is going to be what? 360 degree. Meaning that the formula for this theorem 4 is sum of exterior angle will be equal to what? 360 degree. That is what this theorem 4 is talking about. So when you add up all the exterior angle you are given in any angles, then you will equate it to what? 360 degree. Or you say 4 right angles, because 4 of right angle will still give you 360, simply because right angle means angle at exactly 90 degree. Now let's do some examples based on this theorem. So now let's move to examples. We have 3 examples on the board right now. Now the example 1 says the angles of a triangle are x, 2x and 3x. Find the value of x in degrees. The example 2 says find the interior angle of a regular polygon which has 6 sides. While example 3 says the angle of a quadrilateral taken in order are x, 5x, 4x and 2x. So find these angles. Now let's move to example 1. The example 1 says that the angle of a triangle are x, 2x and 3x. So let me sketch a triangle for this. So let me give it angle A, B and C. Let's assume the angle A is the one for the x, B is 2x and C is 3x. Now from the first theorem which says that the addition of all the angles in a triangle equals to 180 degree. That means angle A plus angle B plus angle C equals to 180 degree. Now what is angle A? That is x, plus B is what? 2x, while C is what? 3x, equals to 180 degree. So x plus 2x plus 3x giving us 6x equals to 180 degree, and we have it as x equals to 180 degree over 6, and that is what? 30 degree. 30 degree. So meaning that this angle A represents 30 degree, angle B represents 60, because 30 in 2 places, that gives us 60, while angle C represents 90 degree, because 30 in 3 places gives us 90 degree. So the addition of all the angles in this particular triangle equals to 180 degree. Now let's move to example 2. Example 2 says that find the interior angles of a regular polygon which has 6 sides. Now remember, the formula for a regular polygon is what? Find the interior angle of a regular polygon which has 6 sides. Now, what is the formula to calculate what is the formula to calculate the sum of interior angle in a regular polygon? Like I said earlier in theorem 3, yes, theorem 3, which says that the sum of interior angles is equals to what? Either you say n minus 2 times 180, n minus 2 times what? Times 180 degree, or maybe you say 2n minus 4 times 90 degree, still means the same thing. So what is n? The n is 6, and that will be 6 minus 2 times what? 180 degree. Now if we have it like that, definitely we are going to say 6 minus 2 is 4. So 4 times 180 degree. 4 times 180 degree, that will actually going to give us 4 times 0 is 0, 4 times 8 is 32. So write our 2 here, put 1 there. 4 times 1 is 4, plus that 3, that is 7. So 720. The sum of the interior angle of a regular polygon is 720. But we are asked to look for what? Just a particular angle. Because from here it says that find the interior angles of a regular polygon which has 6 sides. So this particular 720 means that the addition of all the angles in an interior angle. So for we to now know what angle is going to be one out of all the 6, and that is going to be what? 720 degree over 6. And if I should divide 720 divided by 6, That's going to give me 120 degree. So meaning that out of all the 6 sides we have, one of them or each of them are 120 each. So if you sum up all the interior angle we have, then that's going to give us 720. But one out of all these 6 sides, or all the 6 angles, then that gives us 120. 120 times 6, or 120 in 6 places gives us 720. Now let's go to the third example. The third example says the angles of a quadrilateral taken in order x, 5x, 4x, and 2x. They now said find these angles. A quadrilateral is an angle that has 4 sides and it has 4 angles, such as rectangle, kite, trapezium, parallelogram, and others. So they said here is x degree, here let's say is 5x, here is 4x, and here let's say it is 2x. Let me name here A, B, C, D. This is just a sketch. A quadrilateral can either be a rectangle, can be a square, a trapezium, parallelogram, and others. So they said the angles of a quadrilateral taken in order of x, 5x, 4x, and 2x. Find these angles. How can I know what this x represents? Is by saying the addition of all the angles in a quadrilateral is 360 degree. So giving us that angle A plus angle B plus angle C plus angle D equals to 360 degree. So what is angle A? Angle A is x plus what? 5x plus angle C is 4x and angle D is 2x equals to 360 degree. So x plus 5x plus 4x plus 2x, and that's actually going to give us 12x. So 12x equals to 360 degree, and finally x equals to 360 degree all over 12. So if I should divide 360 degree over 12, so x is going to give me 30 degree. So meaning that this x is what? Is 30 degree. So now they said we should find these angles. Imagine this is a plural this, meaning that we should find what this represents, what this represents, what this represents, and what this particular one represents. So finally, angle A, let me write it here. Angle A is going to be 30 degree like that. While angle B is going to be 5 times 30, and 5 times 30 is 150 degree. While angle C, which is 4x, whereby x is 30, so 4 times 30 is 120 degree. While angle D, which is what? 2x, and while x is 30, so 2 times 30 is what? Is 60 degree. So these are the angles. If you sum up this angle A plus angle B plus angle C plus angle D, everything gives you 360 degree. Now this is example 5 and example 6. Example 5 says that if the exterior angles of a quadrilateral are y degree, y plus 5, y plus 10, and y plus 25 degree, find y. This is a y question actually. So remember that the sum of angles in a quadrilateral gives us 360 degree, and this is even an exterior angle. Exterior angle simply means angle outside, while interior angle means angle inside. So now let me give it a sketch. Let me just sketch any of quadrilateral I can think of. Okay, if I should sketch this now, quadrilateral can be anything, that has 4 angles and 4 sides. That makes quadrilateral. So let me give here angle A, let me say here is B, let me say here is C, let me say here is D. So now let me assume A is the y degree, B, let's say it is the y plus 5 degree, let's say C is y plus 10 degree, and let's say D is the y plus 25 degree. So from what I said earlier, I said the sum of these 4 angles together gives us 360 degree, meaning that angle A plus angle B plus angle C plus angle D equals to 360 degree. That is the sum of all angles in a quadrilateral gives 360 degree. So what is angle A? Angle A is y plus B is what? Y plus 5. C is what? Y plus 10. and then D is what? Y plus 25 equals to 360 degree. So having it like this, how many Y do we have there? Let's add it up. Y 1, 2, 3, 4. We have 4Y plus what? 5 plus 10 plus 25. That gives us 40. So 40 equals to 360 degree. Then let's collect our like terms. 4Y equals to 360 minus 40. Then Y equals to 360 minus 40 is what? That's actually 320. So 320 all over 4. So if I should divide 320 divided by 4, that's actually going to give me 80. That's going to give me 80. So that will be 80 degree. So meaning that Y is 80 degree. So this angle A is ordinary Y. That means it represents 80 degree. Angle B, which is Y plus 5, that means it represents 80 plus 5. That is 85 degree. Angle C, which is Y plus 10, that means it is 80 plus 10, and that is what? 90 degree. And angle D, which is Y plus 25, that means it is 80 plus 25, and that is 105 degree. So if you sum up 80 plus 85 plus 90 plus 105, everything will give you 360 degree. Now let's move to example 6. Example 6 says that a regular polygon of n side has each exterior angle to be what? 45 degree. To be what? 45 degree. So we are asked to find the value of n. Now, how can we find the value of n? You can actually find the value of n by, now this example C says that a regular polygon of n side has each exterior angle to be 45 degree. So you are asked to find the value of n. The right question. Now, from the previous theorem, we know that the sum of exterior angle, exterior angles is what? 360 degree. That's another theorem. It is the sum of, I don't believe it is sum of interior angle. It is that one that is n minus 2 times 180 degree equals to what? Sum of interior angle. Or probably you say 2n minus 4 times what? 90 degree. So this one is also the sum of interior angle, but this one is the sum of exterior angle. Sum of exterior angle is just 90 degree. So now we have to only find the number. That means how many angles did I sum together to give me this particular 360? That is what we are asked to do in this particular question. How many angles did I sum together to give this particular 360 degree, whereby one is what? 45 degree. So what would I say? I will say n times 45 degree equals to 360 degree. So that is what I'm going to say here actually, because of what? N means maybe the number of sides of that particular angle, whereby each of them is 45. So let me know the number of sides or the number of angles this particular polygon is. So I will now say 45n equals to 360 degree, whereby n will be equals to 360 degree all over 45 and 45 degree, and probably n is going to be 360 minus 360 degree divided by 45 is going to give me 8. So meaning that the number of sides we added together to give 360 is what? Is 8. Meaning that 45 degree in 8 places will give us 360 degrees. So our n, which we are asked to find here, is 360 degree. An equilateral triangle. So this theorem 5 actually says the base angle of an isosceles triangle are what? They are equal. Now let me talk more about isosceles triangle and equilateral triangle. So if I have this angle here like this, if I have this angle here like this, whereby, let me say this angle here is angle A, B, and C. The principle of isosceles triangle, whereby all students know, is that two sides are equal. Meaning that if here is 4 centimeter, here too will be 4 centimeter. Meaning that these two particular sides are what? They are equal. So let me use this symbol, let me use this thing to show that they are equal. That two sides are equal. Now, one of the things you should take note in isosceles triangle is that the base angle of an isosceles triangle are also equal. Where is the base angle? The base angle is angle at this particular place. This is the base. This is the base. So the angle here and the angle here, they must be equal. It's a must. That's one of the things you should know when you are talking about isosceles triangle. Not only the side, actually the two sides will be equal. Everybody knows that. But also take note that the base angle, this is the base angle, this is the base, this is the base. So these two angles here will be equal. Meaning that if here is 47 degree, here too will be 47 degree. C is the base. The base angle here must be equal. That is one of the criteria for isosceles triangle. And mind you, if you are now asked to find what angle is going to be this B, that means it's going to be 40 plus 40 and 47 plus 47 minus what? Minus 180 degree. We give you this particular angle for this B in case. So that is what isosceles triangle is all about, and that is what this particular theorem 5 is talking about. Now let's talk about equilateral triangle. In equilateral triangle, which has something like this. Sorry, I'm just drawing a rough sketch. Let me just a rough sketch. Don't mind my angle. It's just a sketch. So equilateral triangle, let me name here. Let's say this is angle A, angle B, angle C. In an equilateral triangle, one of the criteria is that one of the characteristics is that all the sides are equal, meaning that the side here and this side here and this side here, they are equal, such as if here is 10 centimeter, here will be 10 centimeter, here also will be 10 centimeter. Don't mind my sketch, it's just a sketch, because all that three sides, they are not equal. Mere looking at it, but it's just a sketch for me. So one of the characteristics of equilateral triangle is that all the three sides will be equal. Not only that, and the angles for an equilateral triangle will be 60 degree, 60 degree, 60 degree. So these are the two characteristics you should take note for an equilateral triangle. What are they? The two sides, all the three sides will be equal, and all the angles in an equilateral triangle will be equals to what? 60, 60, 60. So when you sum up that 60, 60, 60 together, it's going to give you 180 degree. Let's look at this example we have here, which says calculate the angles marked with letters. Now A is marked with what? Letter A. While B is marked with letter U and letter V. So how can we find the value of this A? Now look at the angle. The angle looks like an isosceles triangle, whereby these two sides here and here, they are equal. This symbol, this stroke here and this stroke here means that they are what? They are equal. So now, and remember what I said earlier, I said the angle for this base here and here, they must be equal. So meaning that if here is 70 degree, this place too will be what? 70 degree. Take notes. So now, how do we look for A? What is going to be the angle for this particular A here? It's going to be, let me label this thing A, B, C. So that will be angle A plus angle B plus angle C equals to what? 180 degree. That's our first theorem, which says the sum of angle in a triangle is 180 degree. So angle A, which is 70 degree, angle B, which is the A, angle C, which is what? 70 degree, equals to 180 degree. So 70 plus 70, that gives us what? 140 degree plus A equals to 180 degree. If I collect my like terms, my A is equals to 180 degree minus 140 degree, and my A is equals to 40 degree. So the angle A is 40 degree. This is very simple and very straightforward. So far we understand the theorems. Now let's move to B. The B says the B2 is also an isosceles triangle. Why? Look at this. This particular thing and this thing show us that this side and this particular side, they are equal. They are what? They are equal. Now, remember this triangle, I can as well draw it as something like this, like this, like this. Okay. If I draw it like this, okay, here can come this way, whereby I have this here. Then I have if I should straighten this thing, let's say if I should turn this thing right like this, so I will have it like this. Yeah. whereby here will be the one for the 56 degree, and here will be like this, here will be like this. So let me have here like this, and my my U will be here. Likewise, my my V will be here. Yes, that angle can also be like that. Like what? By turning this thing like this, look at it as if you are shifting it. So if you turn it that way, you can see how that angle like that still mean the same thing. Yes, it still mean the same thing. But nevertheless, you can solve it like this, or you all rather solve it like this. Anyone is okay by me. So if you are solving it using this particular drawing here, sketch we have here, remember that this place and this place, they are the base. And from this example A, from this A we have here, meaning that the angle here and the angle here, they will be what? They will be the same. So the angle we have here and the angle we have here, they will be the same thing. So now, how do we get the angle here and the angle here? Firstly, what is going to be this particular angle at this place? Look at this. This is angle on a straight line. This gives me a straight line. Angle on a straight line goes like this. And angle on a straight line is 180 degree. So I can actually say 180 degree minus 56 will give me this particular angle here. And that will give me 124 degree. That will give me 124 degree. So the angle here is 124 degree. So if I've gotten this place, which is what? 124 degree, then this angle here and this angle here, this U and this angle here, they are the base, something like this. They are the base for this particular triangle. They are the base for this particular triangle. It's like as if I'm saying here is 124 degree, something like that. So whereby this particular line is the base, so that the angle here and this U will be equal. The angle here and this U in this place, they will be equal. Or you say this angle here and this U here will be equal. So from this principle of what we did here, mind you, here is 124. 124 plus the angle here and this U gives you 180 degree. And remember that anything you get here will be equivalent to what is going to be here. From the characteristics of an isosceles triangle. So which is going to be, therefore, not to waste time, I can actually say 180. Okay, let me do it this way. By saying 124 degree plus what? U plus 2U. Let me represent it as 2U. Because if here and here will be the same. So if here is U, here too will be U. If here is 10, here too will be 10. Because they are the what? Angle at the base. They are the angle at the base. Or you can use this diagram as well. Here and here, they are the same. Because they are the base of this particular isosceles triangle. And the theorem, I think theorem 3 or theorem 2 says that the base, theorem 5 rather. Theorem 5 says that the base, the angle at the base of an isosceles triangle, they are what? They are equal. So that's why I represent here as 2U. U here, also U here. So if you now sum it up, it will now give you 180 degree. So if I should collect my like terms for this particular place, I can actually say 2U equals to 180 degree minus 124 degree. And 2U equals to what? If I should subtract 180 minus 124, that's only going to give me what? It's going to give me 56 degree. So after getting 56 degree, then what is U? U will be equals to 56 degree over 2. And that means if you divide 56 degree over 2, you are going to get 28 degree. 28 degree. That means this U now is 28 degree. And this angle here too is also 28 degree. Let me put it here. 28 degree. Now, how do we get the V? Look at this angle very well. Look at that. Okay, let me use this place. If this U is what? 28 degree. Now, what is going to be this V? This V together with this U, they are angle on a straight line. I repeat, this U together with this V, it is what? Angle on a straight line. And angle on a straight line is what? 180 degree. So how do we get the V? We are going to get the V by saying V will be equals to 180 degree minus what? Minus 28 degree. So this V is going to be 1 that will be 180 minus 28 degree, that will be 152 degree. That is 152 degree. So this angle for this V here is going to represent 152 degree. So we have answered the question by finding the angle for U and angle for V, and we actually say U is 28 degree while V is 152 degree. Now let's look at another example, which is example 3. Example 3 says that in isosceles triangle ABC, side AB is equals to AC, is equals to side AC. If angle B is 55 degree, calculate angle A. Before I move to this example 3, viewers, please, you can actually say that this video is not actually giving the best quality. Yeah, it's because an Android phone is used to record this class. So please, we are soliciting for your help for anybody who wish to assist us or to help us with an iPhone. Please just comment in the comment section if you have got sent to us. We need an iPhone so that we can record better things and then gives you more explanation on chemistry or mathematics and even any of the videos that can help you. Thank you so much as you message us for an assistant. Please, we really need your assistance. We need the assistance in getting an iPhone and also a gadget to record very well, so that at least we can be giving you a good quality video instead of this bad quality video shot with an Android phone. Thank you so much. Now let's go back to example 3. Example 3 says that in isosceles triangle ABC, side AB is equals to AC. If angle B is 55 degree, then calculate angle A. So how do we solve it? Let me sketch the triangle. So let me assume this is ABC. They said side AB is equals to AC, meaning that this AB is the same thing with AC. This is AB and this is AC. So they are equivalent, they are equal. That is why it is isosceles triangle. Two sides are equal. Now, where is the base? This is the base. This angle here is the base. This angle is also the base. So that's the base. So they now said angle B is 55 degree. That means this angle here is 55 degree. So we are now asked to find angle A. That means this particular angle is the angle we are asked to find in question. This angle A. So from the basic theorem we have been working on, we know that if here is 55, here it is also going to be 55. And addition of all the angles, addition of angle A plus B plus C gives 180 degrees. The same theorem we are following, which says the sum of angle in a triangle is 180 degrees, whereby angle A is unknown, angle B is 55 degrees, and angle C is also 55 degrees, which is equals to 180 degrees. So collecting like term, 55 plus 55, that gives 110. So let me collect my like term like that. Angle A will be equals to 180 minus what? 110. And angle A is going to be 70 degrees. So this angle A is going to be 70 degrees because this particular angle B is 55 from the question. This angle C2 is also going to be 55 because this is where the base lies. And from the theorem, which says the theorem 5 says that angle at the base of an isosceles triangle, they are equal. 55 here, this side is also going to be here. If you sum it up and remove it from 180, you are going to get 70. So this angle here is 70 degrees. Now let's move to example 4. Example 4 says that angle PQR is an isosceles triangle in which side P and Q is equals to PR, and whereby angle P is 58 degrees, then calculate angle Q. If I should have this sketch as well, so let me give here the angle, let me give here angle P, here Q, and here is R. So from the question, they said P side PQ, which is this, is equals to what? Side PR is equals to this. The same way with this example 3. So here is the same thing with this. PQ equals to PR, and we are given angle P. So the angle P is 58 degrees. Remember the angle Q, which is this place, and this R, that's our base. So this Q and this R, they will be equal, they will be the same thing. So now what do? We are going to say, if here is, let's assume if here is X, this place too will also be, if here is X, this place too will also be X, because they are the same thing. They are angle at the base of an isosceles triangle. And if you sum up X plus 58 gives you 180. So let me just say 58 degree plus X plus X, that's 2X, equals to 180 degree. So collecting our like terms, 2X equals to 180 degree minus 58. So if I should subtract 180 minus 58, that will give me 122. So X will be equals to 122 over 2, and that is what? 61 degree. So this particular angle Q is representing 61 degree, and angle R is representing 61 degree. But we are asked to find only angle Q. So that is going to be 61 degree. Now let's move to the last example, that is example 5. Example 5 says that the base QR of an isosceles triangle, the base QR, this line is just telling us that is the base. That's just this line is telling us, of an isosceles triangle PQR is produced to S. Let me sketch the diagram here. If we have our diagram here like this, so let's say the diagram is the triangle is triangle PQR. So here is PQR. Then we are told that it's produced to S. It's produced to S. So let me extend this line to S. It's produced to S. And we are told that if angle PRS is 102 degree, PRS is 102 degree. So meaning that I didn't put this very well. Let me rearrange this, because PRS is 10. Okay, it can still be like that. So if R is here and S is here, so PRS is 102 degree. That means the angle here is the one that is 102 degree. So if PRS is 102 degree, the R is the one carrying the angle. So that is why I have to put my 102 degree here. So we are asked to calculate angle Q, meaning that we are asked to look for this particular angle here. That's our angle. And they said the base of the angle is QR. So the base of the angle is QR, meaning that this is our base, QR. This is the base. And remember that if this is the base, that means the angle we have here will be the same thing with what we have here, because the angle at the base, they are equal. So if here is X, here too will be X, meaning that if we have here as our base, this place and this place will be equal like that. So how do we get this particular angle Q according to the question? Because we have to calculate angle Q. So from here we can get out, because anything we get here will be the same thing with what is going to be here, and we can actually get here by saying the sum of angle on a straight line is 180 degree. So if I can actually say 180 degree minus 102 degree, 180 degree, if I say 102 degree plus X, so that will give me 180 degree. So from here I can just say my X will be equals to 180 degree minus 102 degree, and my X will be equals to 78 degree. So if this X now is representing 78 degree, that means this Q, this X2 will be, this Q here too will be 78 degree. So we have our angle Q at 78 degree. Now at the beginning we were told to find what angle is this P going to be, and that would just be 78 plus this 78, subtract the both from 180, and that will give us the angle for this P. So this is a practice question for you. The question 1 says that ABC is an isosceles triangle with its base. The base is what? BC. So if you are constructing or if you are sketching the triangle, ensure that your B and C is the base. Produced to D, meaning that there will be an extension of another line to D. So if angle A is 75 degree, So at your A, you are going to put 75 degrees. Then you're asked to calculate angle ACD. So the C is the one carrying the angle. So that means you have to look for what angle is going to be at C. Now for the example, for the practice question 2, which says that the base JK, so the length, the line or length J and K is your base of isosceles triangle HJK. That's the triangle you are going to sketch. Is produced to L, so you are still going to extend that line to what? To L. So you're now asked to, then they said if angle J is 69 degrees, so at the J, that's where your 69 degrees is. So you have to calculate angle HKL. So at K, what angle is going to be on K? That is what the question is saying for example 2.